So when we're solving by substitution, we generally like at least one of these formulae to be in y-intercept form or gradient-intercept form. And I'll explain why in a second, because when we use elimination, the equations are generally written in general form. So if you have a look over here, so solution by elimination, you can see that those are both in general form. That means that we aren't writing the equation so the y is all by itself. However, see how when we're solving by substitution, they give you one of the formulas in gradient intercept form. Why? Because it becomes easier for us to substitute one into the other. So what we can do, it's always a good idea to label your equations. So I am going to call this first one equation 1, and I'm going to call this second one equation 2. Alright, so you label your equations 1 and 2. And what we're going to do is we're going to substitute, and you need to write this, substitute 1 into 2. So we're substituting equation 1 into equation 2. Now, what the benefit of doing that is that if I substitute this value in here for that value of y, it will mean that in this second equation, I'll no longer have any y's, I'll only have x's. And when I only have x's, I then have the skills to solve the equation. All right, so let's substitute 1 into 2. So y is equal to 10 minus x. So let's write equation 2 using that information from 1. So 3x is going to stay as is, minus 2. Now, this is where it's going to differ. I'm not going to do 2y. I'm going to substitute in 10 minus x for y. So can you see what I've done? Instead of writing y, I've substituted in 10 minus x. So I've taken what was in equation 1 and I've substituted it into equation 2. And this is equal to minus 10. Now, let's expand these brackets, collect like terms, and solve for x. So 3x stays as is. Now, if I expand this bracket, minus 2 times 10 is minus 20. Then minus 2 times minus x is plus 2x is equal to minus 10. Now, let's collect like terms. So I've got 5x's. And it would be 5x minus 20, but because I'm running a bit short of room, I'm just going to do another step in the same step. So if I subtract 20 from both sides, what am I going to have on this side here? Sorry, add 20 to both sides. What am I going to have here? 10. Then, if I divide both sides by 5, x is equal to 10 over 5, which is equal to 2. And now, I can use this value of x to find my value of y. So I can substitute the value x is equal to 2 into either equation 1 or equation 2. It doesn't matter which one I substitute it into. I'm going to substitute it into equation 1 because it's simpler. So if I substitute x is equal to 2 into equation 1, what am I going to get? 10 minus 2 is 8. Can you see? Alright, so x is equal to 2 and y is equal to 10 minus 2, which is equal to 8. Now, let's check if our solution is satisfied, if satisfies the equation. So, if y is equal to 8 and x is equal to 2, on the left-hand side, I would have 8, and then what's 10 minus 2? 8. Does 8 equal 8? Yes, therefore, it's satisfied. And you can always do a check like that. You can substitute your values in to make sure that the left-hand side equals the right-hand side. So, if I substitute 2 and 8 into the second one. What's 3 times 2? 6. And then what's minus 2 times 8? Minus 16. What's 6 minus 16? Minus 10. See how the left-hand side equals the right-hand side? You can always do a little check like that.